Dear students, in this class we are going to see about orbital parameters. So these are parameters required if you want to place a satellite in this particular orbit, maybe low Earth or medium Earth or geo or more than geo orbit. So these parameters are very essential for us. So if you want to place a satellite at any object, we must know about number of parameters. So the very first one is sub-satellite path. So sub-satellite path, how to define the path where we can trace on the Earth surface below the satellite. So say for example, if the satellite is placed in the low Earth orbit, so we must know what is the exact location on the Earth surface. So it is somewhat like you take like a satellite image when it falls on the Earth, so you can measure the particular path distance. And the next very important parameters we have apogee. So apogee, that is the distance where we can measure between Earth center to satellite, and that particular distance is very greater. When a satellite far away from the Earth center, then that particular distance is called apogee. Similarly, perigee. So when satellite comes close to the Earth, and that distance become very small. So the distance between perigee and apogee both are reciprocal, where apogee, that is the farthest distance between Earth center to satellite, and perigee, that is the closest distance between satellite and Earth center. And the next parameter, we are having line of apsides. So we have to draw a line between apogee and perigee. So the line which is going to join between these two points, that is called actual line of apsides, and ascending and descending node. So we have to find the orbital parameters in the direction of north to south. Suppose if you measure the orbit point from north to southward direction, that is called actually ascending node, or if you measure the same thing in terms of from south to north, that is descending node. And a line of nodes, so the same way if you are going to join ascending and descending node from north to southward direction, that is called line of nodes. And inclination, so what angle the particular satellite inclined with respect to orbit, that is called actual inclination. And prograde as well as retrograde orbit. Suppose if you place a satellite in a particular orbit, where we have to identify whether the satellite moves the same direction like a Earth or opposite direction. So if the satellite as well as Earth both are moves the same direction, okay, that is called actual prograde orbit. Suppose satellite moves counterwise direction with respect to Earth, then that is called actually retrograde orbit. And a true anomaly, so we have to find the exact angle with respect to perigee point. What is perigee? That is the closest distance between satellite to Earth center, and from this particular point we have to measure the angle. And mean anomaly, that is the average angle. So here let me see the very first one, apogee. We can see the picture itself. There is a Earth that is available in the middle of the orbit, and satellite revolves around the Earth. And here I am finding the farthest distance, that is apogee, from Earth center to the orbital path. So where we can measure the longest distance or farthest distance. And next one, perigee, we can see that is the distance that is very close to Earth to satellite. So whenever satellite comes very close to Earth, and that particular distance is called actually perigee. And the line of apsides, so line of apsides is nothing but where we can join a line, or we can draw the line between apogee and perigee, and this line must travel across or towards center of Earth. That is very important conditions being a line of apsides. So the line which is going to join both apogee as well as perigee point. And ascending and descending node. So what is ascending and descending nodes? Where satellites revolves around Earth from north to southward direction, that is called ascending node. The same way, if a satellite revolves around Earth from south to northward direction, that is called descending node. And true anomaly. So here now we can take perigee distance. So what is perigee? That is the closest distance between satellite to Earth center. Now the satellite, satellite is available in perigee exactly. Now we just measure the angle. So between where to where? Between perigee to that is satellite. Okay. And we know we know about the line of upsides, line of joining nodes, everything we have measured. With respect to this picture, we can understand very clearly. So we have Earth, and around the Earth we have two number of orbits, that is R1 as well as R2. So we have two orbital planes are there. Both are the first orbital, that is R1, that is the distance between satellite to Earth center, that is R1, where the path is actually elliptical path, and the next path, maybe next orbital path, that maybe look like say a circular path, and where the distance between Earth center to apogee or satellite point, it is R2. Now we can have two number of satellites, and these two satellites are following two different number of orbital path. The first one is actually circular path, and the next one is actually first one is actually elliptical path, and the next one is actually circular path. And what is polar orbit? So this is orbit where a satellite revolves around Earth in terms of circular path, and the direction between from south to northward direction. And equatorial orbit, the same way, if you place a satellite in equatorial orbit, and the path followed by a satellite become a circular one, as well as the direction, in what direction the satellite revolves around Earth, from west to eastward direction. And again, prograde orbit. So if a satellite is available, or if it is revolves around the Earth in a prograde orbit, the path is actually elliptical shape, as well as the very important condition, being a satellite in prograde orbit. So satellite which follow same rotation or same direction like a Earth rotation. So if a satellite is available in a prograde orbit, we can say that the satellite which follow a same rotation or same angle of direction like a Earth. And retrograde orbit, again here also the path followed by satellite again is an elliptical path, and the Earth as well as satellite both are revolving opposite directions. Okay, so that's why Earth as well as satellite both are not following same parameters. So satellite which follow some different angle of direction compared to Earth. And we can see two different number of orbits here, elliptical orbit as well as we can have a circular orbit, and how the satellite revolves in both cases. So in elliptical orbit, we comes to know satellite moves from north to southward direction. In circular orbit, it is east to westward directions. And the last one, we can have a geostationary orbit. So what is geostationary orbit? So being as a geostationary orbit, so it has to follow certain conditions. So the satellite, when a satellite placed in a geostationary orbit, the satellite which follow the same angle, same orbital parameters like Earth. So it has to follow the same angle of inclination, same direction. Even if a satellite remain fixed the same in a geostationary orbit, because both the satellite as well as Earth revolving the same direction, same angle of inclination, so everything will be same. And here in geostationary orbit, normally all type of communication satellites are placed in this orbit only, because the distance. Of course, the distance between Earth to that particular orbit around 36,000 kilometers. So obviously, we are going to cover a much amount of area on the global. So in more number of communication applications, we can refer geo orbit compared to low Earth as well as medium Earth orbit. Okay, thank you, students.